Hello guys. Now in the equivalent circuit series 6 and capacitance 1.9 we will discuss about again a square. In previous video we have taken a square and calculate equivalent capacitance across any one branch. That means there are 7 capacitors in 7 branch. This is a skeleton of a cube. Okay. Now capacitances are suppose identical. Now we will solve first. If you take 1 is A and 7 is B, find out capacitance across A and B. That means a cell of potential or EMF V is connected across A and B. Now your duty is to calculate equivalent capacitance across body diagonal. Okay, equivalent capacitance across body diagonal. Now to calculate equivalent capacitance across body diagonal, in this case it is very easy to solve because here the cell is connected across the body diagonals, means charge is distributed symmetrically in between the point 1 and 7. Okay. So now you allow the charges, mark the charges supplied by the cell let Q. It is symmetrically divided into 3 branches, Q by 3, Q by 3 and Q by 3. Then Q by 3 is further in this junction, Kirchhoff's law you can use, it is further divided into 2 equal branches, Q by 6, Q by 6. Okay. Now this Q by 3 is again divided into 2 equal branches symmetrically. This Q by 3 is divided into again 2 equal branches because all are symmetrical. Now this Q by 6 and Q by 6, both the two are approaching towards 6. Combinedly they give rise Q by 3, Q by 6 and Q by 6 from 2 and from 4 they are approaching towards 3. Then they will combine give rise again Q by 3. Then Q by 6 from 5 to 8 along this direction, from 4 to 8 along this direction, Q by 6 plus Q by 6, that is again Q by 3. So Q by 3, Q by 3, this is Q by 3. So finally the charge is Q by 3 into 3. That means total charge is Q. So as per the Kirchhoff's first law, charge distribution is constant. If in this case, if you take the charge distribution into account, then start from point A and reach the point C. Okay. So to reach from one point to another point, suppose I am taking V is from 1 to 7, that is our potential. V from 1 to start 7 I will reach. From 1 to 7 you go to branch first V 1 4, 1 to 4. Okay, 1 to 4, then I am taking 4 to 8 plus V 4 to 8 and finally 8 to 7 if you take like this. Okay, then put the values. The voltage formula is charge divided by capacitance. From 1 4 charge is C by Q by 3 plus 4 to 8 charge is Q by 6, sorry potential is charge Q by 3 by C, this is Q by 6 by C, and 8 to 7 this is Q by 6 divided by C. Okay. So now this is in the left hand side, V is you take in the left hand side, V is total charge given by the cell is C and equivalent capacitance is CAB. Now Q cancels, so 1 by CAB that equal to write 1 by 3C, 1 by 6C and 1 by 6C. These two are this 1 by 3C plus 1 by 3C. This is 2 divided by 3C. Therefore CAB that equal to 3 by 2. This is 3 by 2 C. So this is your value. Okay. Or is there any mistake? Sorry. In 8 to 7 charge is Q by 3 perhaps. Q by 3, I am correct. I have a little bit correction. Q by 3 means this is 3C. 3C means you take 3c, 3c. This is 2 times 3c plus 1 by 6c. You take this is 1 by 6c. So LCM is 6. This is 4 plus 1. This is 5 by 6c. So therefore CAB that is equal to 6 divided by 5c, and this is your equivalent capacitance. Now what I did, my aim is to reach from 1 to 7. I choose a path 1 to 4, 4 to 8, 8 to 7. Suppose if one can choose 1 to 5, 5 to 8, 8 to 7. That means 1 to 5, 5 to 8, 8 to 7. Okay, you can write V17 equal to V15 plus V58 plus V87. You choose this path. Now come to the first point 1, 5. Where is 1? 1 and 5. Charge is Q by 3. That is Q by 3 by C. Charge is 5 to 8. Q by 6. Q by 6 divided by C. Then 8 to 7. That is again Q by 3C. Mark these two equations. These two are exactly same. Though we are moving in different branch. That means CCC. 2 times Q by 3, 1 times Q by 6 comes in every branch. If you imagine, we will go from A to 7 from this line, upon line. 1 Q by 3, 1 Q by 6, 1 Q by 3. If you go from 1 to 7 through this line, then Q by 3, then Q by 6, then Q by 3, this line. So if you go from 1 to 7 through body diagonal across any branch, finally you will get this answer. Okay. Now let us discuss across the face diagonal. I am taking 1485 is one face. Okay. For well explanation, just to imagine, this is a skeleton. This portion is blank. You imagine the pillars, the lines. Pillars means the lines only, and in between the lines there is a capacitance. Now this portion 1584, this is a ground. 1584, this is a ground, and 5678, this is a up. This is a up. This blue part. This is a green part. Ground. This is a up part. Imagine there are 4 pillars. They are connected. 4 pillars means 2 1 6 5, then 7 8, then 3 4. There are 4 pillars. Okay. Suppose imagine if I will construct this a body, it is not a cube. Imagine these are the wides. This portion is suppose somewhat large, and this portion is somewhat length of wire is small, but there is a capacitance in each and every branch. Our aim is to calculate equivalent capacitance, but not to measure the length of a wire. Okay. If you imagine, if we pull this wire to this side, this side, and this side, what happens? This portion will flat, it will move towards vertically down. If you go on pulling in such a way that this line will represent suppose 180-degree turn, then this portion will fall, appears to fall on this base. I am writing a diagram, just observe. Now this is 1 2 4 5. This is 1 2 4 5. This is 1 2 sorry 1 4 1 2 not 1 5 8 4. Yes, 1 5 8 4. Suppose I am taking 4 capacitances as it is in each branch, 4 capacitances. Then if this portion 5 6 7 8 falls on that floor, then I am taking here, this is you take this is 5 6 7 8, put some every branch there is a capacitance. Okay. Then you take the pillars. These are the pillars. Now the pillar is in between 7 to 8. There is one pillar. Okay. In between 7 to 8, in between 7 to 8 one pillar, 5 to 6 another pillar, 1 to 5 another pillar, and 8 to 7 another pillar. Now where is A? A is at 1, and where is B? B is at the 1584 asla, that is 5678, 5678, no 2637, sorry, this is 2 6, this is 7, this is 3, 2673. 2 lower part, this is I am shaded lower part, this is upper part, 2673, 2673, 2673. Okay. Now AB is in which direction? This direction is AB. B is at 8. So you take this line. Our aim is to calculate equivalent circuit along this diagonal. If you want to calculate equivalent circuit along this diagonal, then perpendicular to this line, that is called symmetrical line. This is a line of symmetry. This is a line of symmetry, and perpendicular to that line, potential remains the same. That means potential across 5 and 6 remains the same. Potential across 3 and 4 remains the same. Therefore, these two capacitors are not used. These two capacitors are not used. If they are not using, I am taking this diagonal as like this. This diagonal is like this. Small diagram I am drawing. This is 1, this is 8, 1 and 8. Okay. Then come to this is 1 and 8, this is 2 and 7, 2 and 7. Okay. In between 1 and 2 there is a capacitor. In between 7 and 8, 7 and 8 there is a capacitor. Okay. So now along this line, that means 5 and 6, 5 and 6 there is no capacitor, and 3 and 4 there is no capacitor. Here there are capacitors. Okay. Here there are capacitors. This is, so this is A and this point is B. Okay. This is A and this point is B. Now how can you find out the equivalent capacitance for their equivalent capacitance for their? You take this is upper, this portion, these two, then this is this portion, then these two are, then these two, then finally this is, and lastly there are another branch. This is one branch, two branch, three branch. All the three branches are parallel. That is first branch and third branch, they are identical. You take this as a and this as a B, and it is easy to calculate the equivalent capacitance now for you. Therefore, after solving you get CAB, that equal to 4 by 3C. 4 by 3C. Let us try to solve it. You solve. If the capacitances are identical, this will be your answer. Okay. If you like this video, mark this time I am taking this line as this. This is called line of symmetry. Line of symmetry. This is line of symmetry, and perpendicular to this branch, this diagonal are equipotential. And these two are equipotential. Okay. As per the Kirchhoff's law, potential at 5 equal to potential at C, that means V5 equal to V6, this is V3 equal to V4. Therefore, these two capacitors are not used. It is not necessary to take that capacitance into account. So this is your cube. We have discussed in previous video a cube having one side across equivalent capacitance across one side. This is equivalent capacitance across body diagonal. This is equivalent capacitance across face diagonal. And you can repeat this equivalent instead of capacitance. While discussing about electrical resistance, you can calculate equivalent resistance if instead of capacitance identical resistors are connected in the same diagram. The process is the same, but formula is different. Here series, they are parallel, they are identical. Okay. Now if you like this video, subscribe and share it. Thank you.